Now let's look on your Agile Mind Books, page 56, number 7. We're going to look at this one. It has a couple of funny transformations we have to pay attention to. It starts out the same, where we have our parent function of 2 to the x. This guy over here, that's our parent function. And then we have this transformation function over here, where it says g of x, where we normally have our a times our base to the x minus h plus k. The one thing we need to notice here is that our bases actually have changed. We have a 2 here and a 1/2 here, which means not only do we have our a, h, and k transformations, we have that reflection across the y-axis that we saw in the last one in number 5. So what we're going to need to do here, this means we need to multiply our x values, x times -1 during our transformations. So we need it to reflect across that y-axis too. Whenever we have a different base in there where it's made a reciprocal or fraction, it means our x has also been multiplied by -1 to make it a fraction. Everything else is going to stay the same. We just need to be really careful with that. So we're going to have our x minus 2 tells us our h. Our h is positive 2. And our k is this number here on the end, that minus 2. So our k is minus 2, which means we have our transformations of a reflection across the y-axis. That h of 2 says it's going to go right. I don't know why that said my board stopped working right. Right 2. And then our k says it's going to go down. Oop. There we go. Down 2. So let's go ahead and get working on this and see what it's going to look like. So we're going to have our x and our f of x values here. Our parent function isn't changing. Nothing's changing about it. We're going to have our -2, -1, 0, 1, and 2. To get our x value, or our f of x values, 2 to the x of 1/4, 1/2, 1, 2, and 4. And don't forget about our asymptote over here at y equals 0. So we've got that horizontal line that our graph's not going to touch for our parent function. And then we've got our points here, -2, 1/4, -1, 1/2, 0, 1, 1, 2, and 2, 4. Like this. This is our parent function, something like this. When we go to do our transformations, we treat this reflection on the x very much like a b value. We did this with our square roots, with our b, and it would multiply against our x. So we'd go times -1 here, and then we're also going to add the h plus our h of 2. So we're going to have our -2 times -1, so that's going to be +2 plus 2, which means this is going to be 4. Then we're going to have this -1 times -1, so we're going to have +1 plus 2, and we're going to have 3. 0 times -1 is 0 plus 2, and we're going to have 2. +1 times -1, and we get -1 plus 2 is going to be 1, and in this one we're going to get a 0. So this is how we're going to get the x values for our transformed function. The y values are exactly like we've done before. We're going to take our k. We'd multiply by our a if we had one, but we don't have an a on this one. We're just going to add k here. So we're going to add -2. So 1/4 plus -2 is going to give us -1 3/4. 1/2 plus -2 is going to give us -1 1/2. 1 plus -2 is going to give us -1. 2 plus -2 is going to give us 0. And 4 plus -2 is going to give us +2. So when we graph these points, our new x and our new g of x, in the table they don't look all that different. But we've got to be very careful with those x values, because what we're starting with now is we're starting at 4 and getting negative 1 3/4. So down here. Then we're going left. We're going to 3 and negative 1 1/2. Going left again, and we're going to have 2 at negative 1. Then we have 1 at 0, and we're going to have 0 with a point at 2. We also need to remember our horizontal asymptote at our y equals k. So it's y equals negative 2. So negative 2, we have this asymptote before we draw our graph in. There we go. So we draw our graph, and we're not going to touch that asymptote, but our graph has this time been reflected across our y-axis because our base was flipped. It had the reciprocal done, or we had that negative on our x. So be really, really careful about that. Our domain hasn't changed for either one of these. It's still negative infinity to positive infinity. Our range on our parent function hasn't changed, negative, so our negative infinity, positive infinity. Our range is still 0 to infinity. And our range on our transformed function, the lowest it can be is that negative 2, and it's still going up to infinity. So our range isn't really changing all that much with the reflection. It doesn't change. It's just scooching down because of that k value. So just be really careful. Watch the base. If the base flips, then you've got to add in this transformation on the x value.